Now, I'm going to change track a little bit here and show you this stuff. This is, I reckon, the coolest stuff you're ever going to see. Anybody hazard a guess at what it is? Yeah, buddy, liquid nitrogen. So as you can see, it really is a liquid. It flows like water. Now, does anybody here hazard a guess at how cold liquid nitrogen is? Yeah, mate? Yep. Bingo, 200 degrees below zero. Now let's put that in perspective. So in the middle of summer, in Brisbane, we'll get up to about 40 degrees Celsius. Coldest day in winter, middle of night, we'll get to about zero. Your fridge is at about 4 degrees. Your freezer's at about minus 16. The coldest place on Earth, Antarctica, middle of winter, will get to about minus 80. This is minus 200. So it's incredibly cold. Now, obviously with something as cold as this, we can have a lot of fun. And I'm going to show you how much fun we can have with that today.
And Andrew, aren't you feeling something?
No, we're just going to have some fun. Is that cool?
No. Safety.
No, we'll just have some fun. It's all right.
No, you can't play with the liquid nitrogen without safety gear. All right? Guys, obviously, I know this is being a bit of a killjoy, but this is very, very cold stuff. You do need to be safe when you handle liquid nitrogen. That's why we have the gloves, lab coat. I was at the back of the line when they handed out lab coats, okay? And safety goggles. So, obviously, liquid nitrogen is very, very cold. If you didn't pick that up from Andrew's speech, he's not doing his job properly. So, there are several very important safety rules you have to go through before you can even touch the liquid nitrogen. All right. So, number one rule of liquid nitrogen is never ever allow the liquid nitrogen to come into contact with you. This makes sense, okay? Liquid nitrogen is incredibly... Please, no, this is serious, guys. Please. It's very, very cold stuff. You think this is funny, but this is serious. Serious stuff, okay? Please listen to me. If it comes in contact with you, it sucks your body heat away and you will die. Okay? Serious, serious problem. Rule number 2. I can't just take... There we go. Okay, rule number 2, and this follows on from number 1, never ever spill the liquid nitrogen on your clothes. Your clothes are next to you. They will come in contact with you, suck... Please, guys, seriously, okay. That was the second rule. Rule 3, never ever drink the liquid nitrogen. All right? No, seriously, don't. Seriously, don't drink the liquid nitrogen. That really would be stupid. Now, obviously, we are having a bit of fun with you here. You don't really need all the safety gear. I can put fingers in the liquid nitrogen, spill it on the skin, and I'm actually all right. All right? Any ideas why this is happening? Why am I not freezing into a human popsicle? Or up the back? Very good. Compared to the nitrogen, I'm really hot, okay? I am at a much higher temperature than minus 200 degrees Celsius liquid nitrogen. So when it contacts me, it flash boils. It turns into a gas. And that provides a protective layer of gas between me and the liquid nitrogen. Obviously, this doesn't work over time. If you stick your finger in the nitrogen and go, cool, then your finger will freeze. You can smash it on the desk. You can only do that 10 times, and this isn't a good time. All right.
Okay, so I'm going to show you one of the most important, possibly the most important skill a physicist can have, and that's the ability to make balloon animals. So it's a little known fact, Albert Einstein was actually incredibly gifted at making balloon animals. He funded his time as a PhD student by working in the Munich circus as a clown. So here we have a little dog. His name's Fido, Fido, say hello to everybody. Hello. Everybody say hello to Fido. Hello. Now, what does every dog need? A dog needs a dog house. And it just so happens we have a dog house right here that comes with air conditioning. So, Fido, do you want to go check out your brand new home? No. Oh, I think he does. No, I love you. Oh, yeah. Okay, so Fido wants to go home. Oh. Now, do you think Fido's happy? I don't think Fido's happy. But that's because Fido's lonely. Fido needs some friends to come visit him. We have a friend for him right here. You want to go visit your buddy Fido? No, I hate... Oh, they're really close. You think Fido's a bit happier now? I think he's a little lonely. In you go. I think they're a little lonely. In you go. That's better. That's better. But they're a little lonely. Parrots flying in. Flying in. Oh, you got a pretty flower. Any biologists tell me what kind that is? They're having a bit of fun. They're having a bit of a party. But what does every party need? Balloons! More balloons! That party's having some fun. So, there's no hole. How is it I got to fit all those balloons in this one box? Yeah, buddy? Exactly. All the air inside the balloons shrinks when you cool it down. So at the moment, the air is made up of millions and billions and trillions of particles whizzing around. The higher the temperature, the more energy they got, so the faster they move. If you slow them down, they don't move as quickly, they don't take up as much space. So the volume of gas inside gets smaller as you cool it down, and that's how we can fit so many in there. So what would happen if we were to pull the balloons back out? They should reinflate again, right? So let's see. So it's kind of flat like a pancake. And I'm just, as it heats up, this is how you blow a balloon up from the outside. Now, as you can see, it's as good as new. I'm going to pull that first blue balloon back out. Now, I'm going to hold the balloon right in front of my head, so hopefully the camera can get it. I'm going to move it about, and I want you guys to look really closely. Do it on the big screen, it'll be easier to see. Look at the bottom of the balloon. You might be able to see something in there. Can you see down here? Yeah. Can you see? It looks like a liquid swishing around. Yeah. Anybody know what that liquid is? Just shout it out. It's liquid oxygen. So oxygen turns to a liquid at about minus 180. So we're actually cold enough for it to turn into a liquid and stay there for a little while. So if Chris wants to come out and help me, let's get all our little friends out and see how they're looking. So here's the flower. And a dog. And for the most part, everybody's back to normal.
Okay, guys, so on a bit of a different topic now. Let's go from ice to fire. Now, does anyone here know when the last volcanic eruption in Australia was? Anyone want to have a guess? Yep. Very close, and you're the only one guessing. It was actually about 5,000 years ago in South Australia. Okay? And now I can see a couple of people in the audience thinking, why am I talking about geology in a chemistry and physics show? So I'll try to get to the point here. Does anyone know when the next volcanic eruption in Australia will occur? Yep. Today. Very close. According to my watch, I reckon it's going to be in about 1 minute. Okay? So with this volcano demonstration, I want to alert your attention to our starting material here. Okay? We have a mound of this orange solid here. All right? And this volcano demonstration is going to demonstrate chemical change. So pay particular attention to how that looks now and pay attention to how it will look after it has been reacted. So, what do you think we need to make a volcano erupt? Yep. Who said that? Exactly right. Fire. So, without further ado, it's been about 1 minute, so I'm going to make this volcano erupt. Okay, so here we have a volcano erupting at the moment. We saw the sparks there. There's a lot of production of oxygen, of nitrogen gas and steam. But as well as that, we have a huge mound of volcanic ash there. So remember how I said at the start to take note of the appearance of that starting material? Remember that small bit of orange solid we started with? That is now a huge mound of volcanic ash there. Okay, so that shows a chemical change reaction.
So we had those 3 rules before. You should never touch liquid nitrogen. You should never have it come in contact with your clothes, and you should never ever drink liquid nitrogen. Now, I wonder if that goes for eating liquid nitrogen, or at least eating things cooled in liquid nitrogen. So here I have burger rings, nothing fancy. I'm just going to dip them in there so that they cool down. Whoops. Now, I would ask, do you think I'm going to be allowed to eat this? But bet you're all going to go yes, because I'm standing out here with food in it. But let's see what happens. You don't want me to? You're worried about me. That's sweet. We'll put a vote. Hands up, who thinks I shouldn't eat this? Thanks. I realise you care. That's nice to know I've got friends. Who thinks I should eat it? That's all right. You guys can leave. All right. Let's see how we go. So what you actually see coming out isn't actually smoke. It's cloud. So when we breathe out, you have a much higher humidity content of the air you're breathing out than what you're breathing in. It's the moisture in your body escaping. Now, when that moisture cools down, it goes from a gaseous phase. So you know how you boil a kettle, you can see the steam coming out? So that's water in a gaseous phase. It gets that and it cools it back down to a liquid. It's water condensation. And that's what clouds are.